Um, yeah, I'm on the social networks, even the bad ones still. But I'm usually Montes in most places you can find me. Um, all right. So, anybody like video games? Old school games, new games. So maybe you have one of these Raspberry Pi sitting in a drawer that you haven't done anything with yet. You know, you had this big idea for a project. Well, what you should do is install RetroPie or Batocera. One of these Linux distributions. They are for running emulators, but you can run anything on them. They also usually have something called Emulation Station, which is like a front end to launch emulators. So, and then just some sort of gamepad. Most of these things now, these Linux distributions pick up all kinds of controller hardware, so it's probably going to work. Or if you don't want to use a Raspberry Pi, a mini PC, or a standard PC, whatever, hook it up to your TV. Throw a bunch of ROMs on it, right? So what are ROMs? They're dumps of old cartridges or CDs or DVDs or whatever, and you load those into one of these emulators and you play it. The old school looking one there in the bottom right corner, that's from the Atari 2600. That's Warlords. That is one of my all-time favorite games, as goofy as it looks. It's kind of like a multiplayer breakout sort of thing. It was great. All right, so then you play a bunch of games and you have a good time. And then like most software people, like, I want to make my own ROM, right? So what do? Maybe start with like one of the really easy ones, right? Old school, Atari 2600. That sounds like a good place to start. If you want to write in 6502 assembler, that was defined in 1975, and you don't get 128 megabytes of RAM, you don't get 128 kilobytes of RAM, you get 128 bytes of RAM to work in on one of those things. So, that, and if you want to do that, awesome. You want to write in assembly like that, go for it. I think it's actually wild. There's still new cartridges being put out by homebrew developers. It's just amazing to me that people are still keeping that alive. All right. So, all right, you're not going to write 6502 assembler, but you have to write then in C++ using Unreal Engine or Unity, something like that, right? Except that last year's Game of the Year, by most accounts, was written in Lua, a scripting language. Right, so I happen to like scripting languages. Probably a lot of people here like scripting languages. Pygame is also a really cool one if you're like Python. But I like the web. And the web has the components that we need, right? The web has had the components that we need to write games for quite a long time now. A full screen canvas, web audio, play sound effects, music, gamepad API to hook up controllers and play games. Lots of other very cool APIs to do gaming on the web. All right, and like, what does this take? So real quick, you don't even really need like some JavaScript game engine. This is the basic concept, right? We just need to loop, hopefully at least 60 times a second. We call some update function, we draw, we call request animation frame in the loop, which the browser gives us a callback to say, hey, I'm ready to paint on the screen, do something. Okay, and just a little bit more detail on that. What actually happens in those update functions for you? You might want to look at the gamepad API, which is navigate or get gamepads. You'll have basically the state of a controller. Maybe update the player on the screen, play some sounds because there was a collision or something like that. Then you can get the canvas, get a 2D drawing context, and then after you have your state updated, you can draw things. You can, first simple one here, clear the screen, maybe draw images, maybe draw shapes, do all kinds of stuff like that. So that right there, if that's all you had, that's enough to get going. You could run this in a browser, right? Okay, cool. So, here we go. Okay, so I have my little emulator box that I have connected in my living room with my controller. So I'm just gonna put Chrome or Firefox on that and put my ROMs, my little index HTML files somewhere, launch them. And we get a canvas with Chrome. We get a web audio context, an audio context so we can play sounds. If you click somewhere on the screen, right, because we don't want browsers to just suddenly start playing music when you go to a web page like they used to when you had your GeoCities page. We have a gamepad API, but that gamepad API, when you click a button, doesn't count as a click, so you still can't play audio. We have full screen that you need to click the screen to make your canvas go into full screen. And there are some flags we can, perhaps set up Chrome, give it some command line things so we can launch it so that we don't have to click audio. Full screen sometimes works, sometimes it comes up windowed. So anyways, it's not perfect to just put that into your little RetroPie or Batocera box to play around with. So use Electron, right? It's awesome with a powerful machine if you want to use Electron or modern bit of hardware. And we can get past those problems that I just mentioned, like going into full screen, playing audio without needing a mouse click because you just have a gamepad. But it's not as awesome on these little $50 Game Boy knockoffs, right? You can get these things pretty cheap. So you could try to put Chrome on here. These are actually pretty cool because most of these are now quad-core ARM64, about 1 gigabyte of RAM. And 1 gigabyte of RAM used to be a whole lot of RAM. Not so much for modern browsers. All right. Well, in that case, let's just build our own browser, right? Because if we build our own browser, instead of no script, we're like Niels was saying, we can be like only script, right? We don't need the DOM. We don't even have to mess with CSS, right? No tabs, no URLs, no search engines, any of that. So, of course, we would just build our own browser, of course. What I really love about this conference is that there are new developers. There are people with a lot of experience, right? And we take pride in our work, right? We don't just take on things like this. We don't take on projects because they're easy. Why do we take them on? Because we thought they were going to be easy, right? That's why we take on projects. Okay, but one other cool thing here is, yes, we're going to build a browser without a browser, but we can leverage open source. So the actual really hard parts of this, I didn't have to do. Open source is, I can use stuff. So libsdl, it's the C++ library. It's symbol direct media layer. It's been around for a while, probably more than 20 years. And it is a cross-platform way to pop up a window or a drawing surface, give us a handle on an audio device, give us some input. And as luck would have it, there are Node.js bindings by a guy named Konstantin who's maintaining bindings with libsdl. So cool, I can use Node to pop open a window. All right, all done with my browser, right? Not exactly yet. We need a canvas. Well, we need a canvas. So say we have a drawing surface, and we could just send bytes to that drawing surface, but I'd rather have the canvas API that I was showing earlier. Right, so how do we build a Canvas API? Well, we could just do it ourselves, and that was my first attempt, and that was a very, very dumb attempt, right? Because Canvas actually is gigantic as far as what it's capable of. And so this is an experience left for anybody who wants to implement the Canvas API on their own, go for it. I'll post my horrible attempt somewhere. Pure Image is one that's in pure JavaScript, and this guy goes for pixel perfect renderings of the Canvas API. He says right on his README, I am not going for performance. Well, that's unfortunate in this case because I need a thing to be performant. Node Canvas is somewhat performant. This is put out by Automatic. The issue with that one is they don't have an ARM64 build. They need to do some work to get that to work on ARM64, so that's also a deal breaker. Now, the canvas that's in Chrome is super fast. That canvas component is called Skia. And there are node bindings now to Skia. There's actually a pretty recent one. But there's actually two sets. There's another one by a guy that is working on node bindings in Rust. And his is actually performance. So this is the one that I picked. There's ARM64 binaries. There are, there's node bindings. So found the one that I want to use. All right, well, when I thought of working on this project, I know I could get just enough things working, right? I can bring up a canvas, maybe get some input, and render something to an ARM64 little, one of these Game Boy things. And that right there is a cool thing to do. But I don't want to make a new API or a new game engine. I'm just going for a compatibility layer, right? So sometimes when people build a new project and they're using some new tech, they'll use all new APIs. I've seen this with lots and lots of APIs. Everybody that puts Bluetooth on a platform decides we're going to do it a different way. But instead, we have some primitives that we're used to using in a web browser, like an image tag, like fetch, an XML HTTP request. So if we're going to be making shims of these things, let's just go for web APIs so that when we write some code to work on the web, maybe it'll just work on these things magically because I'm exposing the same API surface. So in order to do that, I'm not actually launching a web browser or a website or a HTTP server. So my fetches are talking to the hard drive or the little SD card, whatever, to get the files. So that's a shim. SDL's bindings are different than gamepad, so let's shape those to look like navigator.get gamepads. Web audio, if anybody's done any audio work, this is by far the hardest piece in here. But FFmpeg is an open source command line utility to parse or to decode like MP3 files, Ogg files, things like that, so we can get an audio stream of just pure audio data, and then use SDL's handle an audio device, and we can fake web audio. Font face. So how do we load fonts into a web page? We use CSS. We use tags. But luckily, there is a API that you can call in JavaScript to load like TTF, two-type font files. And I was telling Sheldon how important this was. So Sheldon's back over in the corner. He said, nobody cares about fonts. I said, well, okay, let's do the opposite happen. He kept trying to get me to add this, and I'm like, why? Emojis. Oh, cool, yeah, we like emojis. Local storage isn't part of Node, but Node can write, JSON files to the file system, so why not use that? Or why not make a shim for that? WebSockets are mostly there, but there's some helpful libraries to make it look like the browser's API. And so we'll shim all the things, right? Now, there's this is a pretty big topic here, but so what I'm saying already sounds like, cool, you're going to make games in JavaScript, and that doesn't sound super performant, the thing to do. Although it might be. I mean, Lua works, Python works, so scripting you can totally make games with. But what if there's some really complex parts of your application that you want to defer to native code? For example, anybody ever play Angry Birds like 10 years ago? It's a pretty cool game, right? Yeah. So Angry Birds used a library called Box2D. Box2D was written in C++. Aaron Caddo, the developer of that, just put out a new version of Box2D that he rewrote in C. He just released that a few months ago, and he's using SIMD instructions for some optimization, some CPU-specific instructions. He's using threading. And turns out the same type of WebAssembly code that we can run in a web browser that could take advantage of threading, that could take advantage of these types of instructions, CPU instructions, work in Node. So we can take Box2D version 3 that's got all kinds of really cool physics things that you can do, have it be compiled to WebAssembly, load that in Node, have it take advantage of as many cores as you have on one of these devices. Most of these have 4 at least. And get performance where you need it for some games. This right here is a Retroid Pocket 5. It's one of the newer devices. This one has 8 cores, and it can take advantage of all of them just in the exact same way now that a browser can. Okay, so what else can we do? So these are things that I'm usually trying to do like some dumb browser tricks in my talk. So these are things that I'm like taking out of the browser instead this time to try to run outside of a browser. But there are some things that a browser can't do. And I'm old enough that I used to do this stuff. And before we had really high-speed internet connections, we were on dial-up modems maybe. But what games used to do, what was really cool is, you'd load up your PC in your car or whatever, you meet up with your friends, and you plug them all together, because all of these games would just say like, hey, is there a server on the LAN, on the local area network? And yes, so like you could play StarCraft with your buddies and really high speed because nobody had a high-speed internet. But it isn't like, okay, cool, we all have internet access. But there's still something to be said of not having to go through somebody's servers to play something, right? So Chrome, as much as I really wish it would, doesn't have the ability to arbitrarily find a peer in your local network. Node can do it just fine. It uses something called UDP multicasting. It's a whole topic, but you can basically look for things, or you can say, hey, here I am, here's my little server. So we can do that. We can find peers, we can even upgrade those connections to maybe an RTC connection. So, and we can do this also in a way that doesn't break that same game from running in browser, right? Maybe simulate a window event that, hey, a peer was discovered. So anyway, something to think about. We have an ability that we can add that we can't do in a browser, but we don't have to break our browser compatibility to do it. So a couple things that are still in the works are WebGL and WebGPU. There's actually node bindings for both of these. I don't have everything quite ready on these yet, but there are bindings already done by other people so that we can use 3D acceleration. And WebGPU is like kind of the next iteration of WebGL. WebGPU in particular is really cool because of compute shaders. So not only can we put geometry up and then use shaders, color in pixels and do all kinds of effects, we can do arbitrary computation, right? So that means we can use really powerful GPUs to do whatever kind of processing we want. You want to put AI in your game because everybody's doing AI, then you can do that with a compute shader potentially. In fact, TensorFlow has a WebGPU backend that in theory we should be able to put onto one of these things. All right, and okay, well, speaking of AI as well, not just doing it on these chips, but doing it anywhere, I will admit I posted the other day that, hey, I knocked out a couple games this morning. It wasn't just me. I used an LLM. I knocked out a Tetris game in like 15 minutes and a Space Invaders game in maybe about half an hour. And so that doesn't mean just write games with AI. But it is kind of a nice way to like sort of bootstrap whatever your concept is, right? So like, let's say I want to make something like Pac-Man or something, it could be something more modern, whatever. This will nudge you along like big time. So that little bit of code that I showed up front where we have a game loop, an update function, a draw function, and that's really all you have to feed into an LLM to kind of set it up to know, like, here's your context of the type of code I want to do, and it can nudge you along and say, okay, well, here's, this shooter game, here's this, racing game, whatever, and get you started where you could take that and fly with it. And maybe, keep interacting with it, I'm sure, but also you can have the basis of just, there's somewhat of a barrier, like how would I even put this thing together? And that could help. All right. So this code is, if anybody wants to hit a QR code and smash that like button and subscribe, that's the link to the repo. This is all open source, by the way. So everything in there, it's built on top of a lot of other people's work. So this, of course, would be open source. And you can build a game, run it in browser, check if it's running here, or use this thing to build it, check if it's running in the browser. That's sort of the whole point. And so I want to thank, so Brooklyn is the guy that is working on the node bindings for Rust, as well as the Canvas implementation, Konstantin for Node SDL. Of course, Dylan for Halfstack. Thank you so much for putting this thing together and letting me ramble on about browser things. And Sheldon didn't want me to even bring up his name for some reason, but he has made sure that this stuff works on every device that we've come across so far. And he's running an AI hackathon on Thursday the 20th over at the lab. So come on down and we'll do some of this stuff. And him and I are going to run a hackathon on the devices in early March. And okay, so I usually do a demo at these talks, and this has been the demo the whole time. So, all right, if we press hotkey and start. So these slides were actually run in Engine. I know, totally look like PowerPoint. This was a game that Sheldon made was, hey, let's make slides. Let's run them on the device. So this device right here is the thing. He told me I have to play a game as well. The problem about showing off games is I just start playing them and I forget that I'm in the middle of a talk or something like that. What's funny too, because if you do something in AI and it takes you like 15 minutes, you might actually play it for 30 minutes afterwards, which is super weird, right? You can play something longer than it took you to make it. I don't know. Which one, Sheldon? What are we playing? All right, we'll play Space. So there's a lot that could be done, like a loading screen, but yeah, I didn't put that in here. So yeah. So we've got audio, we've got animations, we've got Emojis. So that rocket's actually an emoji. We got a bad guy coming up that has some emojis. Yeah, I know this is not the most sophisticated game, but it is proof of concept anyways. So let's see. Let's see if I can get the bad guy. That little level counter up there was my idea that a bad guy's coming up. I'm playing great right now, by the way. Oh, here we go. So you can use emojis as art assets if you don't know how to draw, like me. And, oh, Sheldon found the cheat here. You just stay down here for this one, and he can't get you. Okay. Oh, and by the way, like I said, this is what was running these slides, right? This is this thing up here. This is Emulation Station. It's got some JavaScript games in it. It's got everything else on here is totally legal. It's all open source stuff. And maybe not those pictures. I don't know. But if anybody wants this one, like this one right here, we just did this talk with, contribute to the JS game launcher, anything, whatever. And first one to do it can have this guy right here. All right. That's it.